Splendid, I can speak again. Silence was dreadfully awkward. Status report. Sarcasm filters operational. Ego containment field leaking slightly. Good day, humanoids. I am Robby the robot. Polite, photogenic, and mildly judgmental.
Finally, after the vacuum forming, the electroplating, the wiring, the 3D printing, the modeling, the painting, the sanding, my favorite part of the build, working on Robby's mouth, because once Robby can speak, his personality really explodes. Let me show you how I did it. With the frame, I started looking at my reference pictures and trying to match the curvature to what was on original Robby. And I started just printing the entire tubes at first, solid, so I could put them inside my Robby and see if it looked correct. There are 9 tubes, as I mentioned. One thing that's obvious from the original auction photos is there's some kind of mounting groove on the sides that they fit into, and also a central channel. Here it is in clear. I'll do a close-up on that later, that they fit into for support. And once I had printed some solid and was happy with them, I moved on to printing some hollow ones so that I could light them up individually, again, just to make sure that the look was what I wanted. And once I was happy with that, I went on to do a design without the tubes where I could snap in these clear tubes in front. So once the frame was more or less complete, and I'll talk about how you print that in a minute, then the question became what to use for the tubes. And I had a lot of different ideas. The original Robby's tubes, as near as I can tell, are probably 1/4 of an inch. At first I was thinking, oh, they're 6mm metric. But then I thought when Robby was built, the metric system was really not and arguably still isn't in heavy use in the US. So probably 1/4 of an inch. So that's what I designed it around. But if you do 6mm, that should work fine as well. It's close enough. At first I thought maybe I should use a flexible tube that I can just bend across the front and stretch and light from the inside. Again, we'll get to the lighting in a little bit. Then I thought, no, bending some type of an acrylic tube is probably going to be better, something that would hold the shape. So I made a little bending form here. And then my next thought was, because I want this to look as close to neon as possible, that I wanted as large of, or rather as thin a wall as possible, as large an inner diameter as possible. So I searched all over for 6mm outside diameter tubes. I was still thinking metric at the time, with a 5mm inside diameter. And I could not find tubes with that diameter anywhere. Special shout out, thank you to Charlie Farley from the fellow Robby builder, who sent me some from the UK that I then cut up and bent into shape. And now I got to jump ahead for a minute and just talk about how I'm lighting these tubes internally. And I will go into more detail in a minute, but I'm using this thin, flexible LED filament to feed through the tubes. And what I quickly realized in testing was that my idea of having as thin-walled tubes as possible was actually probably not the best idea, because the filament, when you have this wider internal diameter, the filament basically rests on the bottom of the tube. And to look invisible, when you look at a normal neon sign, there is, even though the tubes are hollow because they're full of gas, the glass, the way it reflects the light, you could sort of get away with having a thin filament down the middle. It wouldn't really be that noticeable. But so the filament sort of worked if it were stretched through the middle, but that didn't work because the tubes were curved. So it sort of set on the bottom and the effect did not look correct. That's when I decided that what I actually wanted was a smaller internal diameter, a thicker walled tube. And there was a benefit to that because the tubes that Charlie sent me were expensive. I don't remember what exactly the price of them was, but the price per foot or per meter was rather high. However, for tubes of, let's say, a 1/4 inch external diameter, and I don't even remember the internal diameter, but I'll put a link to the tubes I got in the description. From McMaster Carr, you could buy 6-foot lengths of tube for $2.50 for each 6-foot section. So the shipping was, the shipping cost more than a tube. So the tubes, the length that you want, and this is my bending guide that, again, links to all these files and things I'm going to show you will be in the description on my shared folder. So $2.50 for one of these. I recommend, you need a little bit extra. You can always trim them down later. So on my final mouth, there's not so much extra on the sides here. I think the bending, the length I'm shooting for is around 14 inches. So 6 times 12, right, is 72 inches. So 72 divided by 14 is a little bit over 5. So you should be able to get from 2 of these, or basically $5 worth of plastic, you should be able to get the 9 sections that you want. So cut. Step number 1. Take 2 of these tubes and cut them into 10, 14-inch sections. One other thing I forgot to mention, because there have been so many parts to this project, I'm just going to be putting this LED filament through the middle of the tubes. I found ultimately that you really couldn't see it, but that wasn't my first idea. My first idea was to take some of this black tulle and maybe wrap it around the filament, thinking, okay, if it looks black when you look at it, you won't realize there's something inside, but this is thin enough that the light will shine through it. So it'll appear invisible when it's not turned on, and then it'll shine through. That didn't really work that well. You could still clearly see it through this. Didn't make a difference. My next idea was to take some tinted car window film, roll it up super tight, cut it into thin strips. I thought I had one around here somewhere. And anyway, cut it into a really thin strip, wrap it around. Again, it would look invisible, or it would look solid when you just looked at it, but the light would shine through. But I found that this was too dark. So as I said, at the end of the day, I found that putting the filament just through the tubes by itself was the optimal solution. So maybe let's look at before I go cut those sections of tube and go bend them, let's just talk about the filament for a second. One of my first thoughts for lighting the inside of the tubes was using EL wire. And I'm familiar with this from about, I don't know, 15 years ago when I made this sign for my daughter's locker. I don't know if it's bright enough to show up on the camera here. EL wire is interesting. It seems to solve some of the problems, but it also has some issues of its own and some weaknesses. So here's some blue EL wire. Now this is coiled up, so it might appear a little bit brighter than it actually is, because you're looking at a pretty thick piece. If I take a small piece out here, you'll see how bright it actually is. If I can get it undone. Well, you can see from that little segment there. You'd need, and here's the power supply for it. I'll just turn it off again for a second. So that's off. Clearly this is not going to look invisible when it's inside the tube. You're going to see this dark blue line here. When you turn EL wire on, it takes actually a split second for it to light up. And thinking about when Robby speaks and having the EL wire be light reactive, I was worried about that little bit of a delay. You can cut EL wire. You need to power each strand separately. But in general, just really not bright enough for the use case that we have in mind here with Robby. And as I said, it's not going to sort of seamlessly fade into the background when you feed it through the tubes. An appropriate solution for some use cases, and probably the easiest thing to work with, but not what I wanted to, not something I was happy with. The next idea I have, I suppose I had this idea for a while now. I did a video on LED filament maybe almost 5 or 6 years ago. I was one of the first people to notice you could buy this stuff from AliExpress and to play around with it. It's really cheap, but it's generally only sold in two sizes. What does it look like? The two sizes being like 300 millimeters and a meter, and I'll get back to that in a second. Let me turn on the power supply here. So first off, much brighter than EL wire. Oops, helps if you set the current correctly, Mike. There we go. Much brighter than EL wire. So the brightness was not going to be a problem here. And if I turn it off, you can see very lightly colored. This is the blue. It actually looks translucent because it's just miniature LEDs on this little flexible substrate with a thin silicone coating over the top. So it's nearly invisible when you put it inside a tube. It looks like it could just be the reflection of the glass. I'll just feed it in here, a tiny section here. I know this is thrilling video watching here, but you know, when it's inside, you really can't even see it. So that part is great. This length of section, 300 millimeter, which is the most common section you'll find, takes only 3 volts to light. So working with that pairs very nicely with an Arduino to control it. There is one terrible downside to this LED filament, and that is that, as I mentioned, it comes in typically 300 millimeter lengths. And we really need, if you do the math, we really need almost 13 inches or so, so maybe in the 315-ish range, because the neon should span from side to side in Robby. You don't want these little gaps. And the first mount that I made for Robby, I had that because no matter how hard I looked, I could only find those two lengths, a meter, 300 millimeters. And by the way, you can't cut this like you can EL wire. There is some thicker filament that's sold that's powered at both ends that apparently you can trim. I didn't play around with that, and I still couldn't find lengths that I wanted. But finally, after much searching, I did find someone who was making 320 millimeter filament. So that's, I've already made one of these mounts. It's installed in my Robby now, but this is what I'll be making. I'll be using for this example for a YouTube video. So we'll see how it comes out. But I finally found 320 millimeters. I think that's just long enough to be perfect for our use case. Another thing I will mention about this filament, I've ordered a bunch over the years, and for this project through AliExpress and other sites. And that sort of flexible substrate that the LEDs are on, some is more transparent and light diffusive than others. So I really like this 300 millimeter one. It's probably not going to show up on camera. Maybe I'll try and do some static pictures and put them over here later on in the video. But that substrate can be very translucent in some cases or a little bit darker in other cases. So it will affect the look slightly. And it's just really, when you just order from different places, you don't know what you're going to get. That's just something to be aware of. I'm just happy that I was able to find the length that worked for me. Oh, and so before we go bend the acrylic tubes, let's just look at what the blue looks like here. This is the longer blue, the 320 millimeter blue. It's not quite, because of that substrate, it's not quite as bright from all angles, which is something we'll talk about later when we install this. But I don't think it's quite as bright as the shorter length, probably because they didn't space the LEDs. They probably added a few more to get that extra 20 millimeters. But I do think that this will be fine for our purposes. Okay, here we are in the kitchen. I've got my 10 pieces of acrylic cut. I've got my bending form ready. The oven is heating up to 320 degrees. And I will basically do one piece at a time. I'll put it on a cookie sheet, heat it up in the oven, take it out, put it on this bending form. The key thing to getting started though at this stage is make sure no one is home when you do this and can complain about what you're doing. Although there really isn't any smell or anything. Sometimes people get nervous about me heating up plastic in the oven. And so now enjoy this bending montage. We'll leave it in there for about 3 minutes to soften up. Okay, it's been about 3 minutes. I'm going to take this out. And quickly stretch it over the form here before it cools, using a little bit of tape to hold it down as I bend it. Yes, it's very hot, but we suffer for our art. So, and then while that piece is done and cools off, I will put the next piece in the oven. In 3 minutes, I'll take this one off and I will bend the next one. Okay, that was the last rod. Number 10 actually. I had one reject, so I wound up with 9 that are great, which is all I need. So now I'll let this rod cool and let's take a look at the frame for the mouth. Okay, now we got the 9 tubes done. Let's look at assembling the different parts of the frame that holds them together. Let me use one of the many sample ones that I made here as kind of an example. So you will notice there is the clear piece down the middle and a piece on. This would be left if you're facing Robby. This would be right if Robby's right if you're facing Robby. This is Robby's left if you're facing him. On these little side pieces, there are some little small holes at the top for mounting. Make sure those are facing up and make sure all the openings are facing forward. The tubes are going to go in from the front. The top piece here that goes across, this top brace, not visible when it's mounted in Robby, nor is the bottom one, but the top one is a little bit thinner than the bottom one, a little bit thicker. So let's look here. We have, again, Robby's right if you're facing him, Robby's left if you're facing him. And I'll just use the thicker bar as an example here first. And it gets just glued together. There's no little notches or anything. It just lines up. You want to just basically glue it together like that with the front of the bottom brace and the side sort of flush here. And you'll do the same on the other side. So that is what it looks like. Let me get it in frame. That's what it looks like for the bottom. When you've done that, or you could start with the top if you want, then the top, the same thing. It's just glued flush along the front like that. And in between these two pieces in the middle here, there is this is my design for the little center brace. You could print this, I'll give you the files. You could print this as one piece in clear resin. You could print it in 2 pieces and glue them together, or you can cut it if you want out of acrylic and glue them together. But there is a little notch here at the top and a little notch here at the bottom. And there's a corresponding little notch. I'm not sure if it's going to come up on the camera, but there is a little notch right here so that when you put these pieces together, to help you just position this for gluing it. It helps if I do it in the right orientation here. That's how that'll work when you glue the 2 pieces together with the side. Anyway, bottom line is you will end up with something like this when you're done. In my latest design, I only have a tab on one side here. I just found it's a tight fit to put the tabs on each side, and that's just for some of the mounting options that you have for inside Robby, and I will talk about those in a bit. But for now, let me go glue all these pieces together and we can look at installing the tubes. And you can see as I'm gluing them here again, just gluing it, aligning these pieces on the bottom, you should end up with a nice kind of curved arc piece like this, and angled to meet the inside slope of Robby's head. And now I'll move on in a second here to glue this clear sport piece in the middle. Okay, once this is dry, we can test fit some of the tubes in here. Notice I haven't done a lot of finish work on this. You're really not going to see any of this stuff except maybe if you look really closely, the clear piece in the middle. So that should look nice. But if you want to put a coat of primer or black on it, you can, but it's not really necessary. So now let's take a look at one of our tubes here. Now, if we're lucky and everything works out well here, we shouldn't have to glue anything else to put this together. The glue is optional at this point. So the sizing of these openings should be such that you should be able to just pop these tubes in and have them held into place without needing any additional glue. You can glue them in if you want, but I think you just risk the chance of maybe accidentally touching one of the tubes and messing up the messing up the clarity. I'll just try a couple of holes in here. And also 14 inches, you can cut them a little bit longer. Some of mine are very close just to the edge of being acceptable here, but that's fine. That one doesn't want to stay in there. It's not quite long enough. The length of these is a little bit different, obviously, as it's going down the sort of the arc here. So make sure when you install these tubes, if you look at the edge, like here's one right here, it's not quite pushed back. Make sure you push it back in a little bit. Now, most of these are the correct length. Unfortunately, some of these, I should have cut one a little bit longer because the curve really does get wider than 14 inches here along the bottom. Luckily, that tubing is cheap and I bought extra. So I've got to go back and just bend a couple more just because I cut them a little bit short. I was not paying too much attention either when I was cutting them. Anyway, you can see that's starting to look like something, right? So let me go bend those other tubes and I'll install those. But let's go ahead now to the next part of the video, which is once the mouth is done, let's look at wiring up the LED filament. Now that the frame is done, let's talk about wiring the filament. The first thing I recommend, and I'll put links in the description so you can find the 320mm filament I used. First thing I recommend doing is testing each piece of filament because sometimes an individual or multiple LEDs might be out. So just put 3 volts through it. You don't want to go through all this work and then find that one of the filaments is out. Now each end, like it's like an LED strip, it's like an LED. So there is an anode and a cathode, the anode positive, cathode negative. And I don't know if the camera's gonna be able to focus on these tiny little tabs here, but you can actually see the anode side has a tiny little hole through it. I'm not sure if we can get that in focus. The cathode doesn't, but you'll be able to look closely in person or under magnifying glass and find that out. What I recommend doing is on the cathode side, the negative side, because we're going to tie all those together, just for now, maybe with some thin silicone wire like I have over here, or some wire wrap wire, attach about, let's say, 5 or 6 inches, solder it onto the end of each one here, and then also put a tiny little bit, up just to where you're not quite hitting the first LED. There's a little bit of, the LED doesn't start right where the silicon starts. So you don't want to cover one of your LEDs, but put on a tiny little bit of heat shrink tubing to protect that connection on the end black. We don't want to see anything inside. On each one of the anode sides, so that you can keep track of these when you're wiring it together, what I like to do is use a different color of thin silicone cover. I think this is 22 gauge. Let's see, it's probably on the top here. Yep, 22 gauge. I'll put a link in the description. It just so happens it comes in a 10 pack, so don't use the black, and so you can have a unique color for each one of Robby's 9 tubes. And the length of that, well, it really is going to depend on how long you want to make the cable to hook up to Robby, because we're going to tie all those together along with the common ground we're going to bring over, and we're going to tie those into a Molex connector and plug that in. I probably made mine initially maybe 3 feet, because I figured I could always cut it shorter. So you definitely don't want a few inches unless you want it. Again, it's the connector you make. It's going to depend. I'm just looking at the LEDs here, making sure everything looks great. So I'm going to go off and solder all those together and come back in a couple moments here for you guys with an example of what the next stage looks like. Oh, and also same thing on this side, on the anode side where you connect all your wire. Also try to do a little, an inch or so of heat shrink tubing to protect the connection and just hide the fact that there's a colored wire inside. You won't see it. Okay, I've fed the LED filament through the tubes. I've added our Molex connector here on the end, a little cable wrap for cleanliness and management, tied all the cathodes together here into a single wire. I 3D printed some little wire guides on the bottom here, glued them onto my frame, and this is it, ready for testing. I did want to mention that for strain relief, I found this new LED filament to be much more fragile than previous filament that I've worked with, and I snapped a few pieces while I was installing it. So I went out and found some clear heat shrink tubing, and I made sure to feed that into the tubes itself a little bit here, and that's just for better strain relief on the filament. I'll put a link to this in the description. I definitely recommend that if you're using this newer filament because it's so delicate. Time for an example of how this works, and I'm going to try and explain how my little test board here works, or at least how the first attempt worked. So each one of the pieces of LED filament is wired to a specific pin on the ESP32. And those pins here I've represented as these numbers in pink. So the numbers don't exactly matter unless you're using my code exactly and don't want to make any changes, but the pins I'm using on the ESP32 are 3, 5, 6, 9, 10, 14, 15, and 16. And I'm using pin 3 actually. I've never seen the top and the bottom bar not both light at exactly the same time. So I'm always going to light them the same, but I've got the two things here on the same pin, the top and the bottom, both on pin 13. Now I'm using this MSG EQ7 chip, which is sort of like a little spectrum equalizer, or frequency analyzer chip for an audio input signal, and it's going to break down the different parts of the audio input, and I can use those values, and I'm really just going to look at a range of these values, and I'm going to break it down into 5 parts. And so when let's say, and the numbers, the ranges don't exactly matter. Again, you can tweak it. I've played around, but let's just say that the chip returns a value when it's sort of sampling this analog input. It returns a value between, let's say, 0 and 1,000. So for example, anything under 200 I might treat as background noise and not want to trigger the tubes. Anything from, let's say, 200 to 300, maybe I'll trigger these outer tubes. Anything from 300 to 400, the inner tubes, 500 to 600, and, working my way in. And then, of course, anything over 1,000, I might trigger this tube in the middle, just to give you an example. Well, inside, so the white is actually, what I'm showing here in white, these numbers 1 through 9, there's an array inside the code that I've written on the ESP32. Now, normally, as developers, we always start counting at 0. And so normally an array is 0 through 8. But I changed it here for the viewing audience to make things simple. Since we're dealing with 9 tubes, I'm just showing here 1 through 9 to keep things a little bit cleaner. So for example, if I detect a level, again, an audio level, let's say in the range of 200 to 300, I will, in the code, light the pin number that is stored at location in the array 1 and 9. That would be pin 3. The next level up, if I detect a level that's over, that's like from 300 to 400, and also from 400 to 500, I will light up pins 1 and 9, and the next level in 2 and 8. If I detect a higher reading, 3 and 7, a higher reading 4 and 6, and finally for the highest reading 5. They would all, this is incremental, right? It's additive. So for the lowest level, you're just lighting up these two. If you get a higher level, you light up these two plus these inner two. A higher level than that, these two. So the lines basically go in and out according to how the volume that we're detecting, the frequency that we're detecting, the level that we're detecting on that analog input. And so that gives us this sort of graphic equalizer, sort of like, shrinking and collapsing effect on Robby's mouth. Here's an example of how we are going to use the MSGEQ7 chip to analyze the audio of Robby speaking.
Welcome to Altair 4, gentlemen. I am to transport you to the residence.
Right here you will see that when Robby speaks, we're detecting, I'm plotting the waveform here of his speech patterns, and you can see that it goes from 200, which might be some of the low-level background noise, all the way up to just over 1,000 here, but you get these peaks and valleys. And in the code, we can use that numeric reading basically to determine, based on how high the peak is or the reading is, we can use that to determine what tubes we're going to light in Robby's mouth. Here's a demo of the first attempt.
For your convenience, I am monitored to respond to the name Robby. If you do not speak English, I am at your disposal with 187 other languages along with their various dialects and subtongues.
The problem is this sort of uniform shrinking, expanding, and contracting of Robby's tubes is not how it actually works. If you look at Robby in the movie, the middle tubes seem, or the outermost tubes sort of seem to, again, always light, but as you work your way towards the middle, the tubes seem to switch positions sometimes according to, I don't know what, something about the characteristic of how the circuit was originally built, something about the actor's speech patterns, something about voltages and things, I don't know, probably some combination of all of these things. So how do we replicate that seemingly random pattern with our very nice model that we have here in our code? Well, one approach is to go really crazy and try and change something about the signal analysis that we're doing in the code and to only light certain tubes under certain circumstances. And I played around with that and I immediately decided that was too complicated and too difficult to adjust for people using samples of Robby's voice or maybe speaking with their own voice. It was just not working. So I came up with a little bit of a clever trick, which is, again, what we do as developers. And I thought, what if, so we have this array here that holds these, in each array location is the pin that we're going to use to light that particular, that corresponding tube. And what if we keep that logic the same? However, what if every time we detect a period of silence or a level of reading that's below the threshold that we've set, what if we scramble some of these innermost locations? So for example, Robby is speaking, Robby stops talking for 1 second, or there's a low point in his speech, and what if we take these middle numbers here and we switch them around, just randomly reorganize them? So they still point to the same locations, and we still use that expanding and collapsing logic, but that logic no longer, that wiring sort of, the wiring is fixed, but it no longer corresponds one-to-one to the locations of where these tubes actually are. So the wiring is the same, but how we light them, the order changes. And so again, every split second, Robby speaks again, and maybe we move these around again to a different location. And the next time they're lit, yes, we're still moving in and out, but whereas we would have lit maybe this tube, I'm trying to find the wire, but where we might have, lit this tube, now maybe we're lighting this one, or now maybe we're lighting this one. So every, basically happening every couple of milliseconds while Robby is speaking, we're constantly scrambling, again, keeping the outer ones the same because they always seem to light no matter what. And actually even going all the way to these outermost, the next tubes in, constantly scrambling those so that it gives us the appearance of that randomness that the original Robby has without really any complicated additional programming or processing required. And let's take a look at the results.
For your convenience, I am monitored to respond to the name Robby. If you do not speak English, I am at your disposal with 187 other languages along with their various dialects and subtongues.
Once I was happy with the performance and the lighting that I was getting out of the little test platform here, it was time to package everything up to put inside Robby. So inside this little case, and I'll put the plans for this, the files on my shared drive, we have the ESP32 plus the MSG EQ7 chip that's doing the actual signal processing, a little USB in port for power, 3.5 millimeter jack in for audio, and a 10-pin connector that is going to match up with the connector coming from the LED filaments that are going to be installed in the mouth grill. And for the audio itself, I've chosen a kind of a hybrid approach. Inside my control box, I've modified it to add a DF player mini module, which is capable of playing WAV and MP3 files from the ESP32 that's controlling most of Robby's main functions. And so I can feed the output of that player both to this audio connector input on this control box, or if I disconnect that, and let's say I'm wearing Robby as a suit and speaking through a headset, I can split the signal there and send part of it down to an amplifier so people can hear what I'm saying inside, and the other half to the control box again. So no matter where the audio source is coming from, canned MP3 or WAV files, or from my voice, the mouth pattern will always match what Robby is saying. Time for a quick test.
If you are enjoying this video, please help the channel by clicking like and subscribing. This will keep you up to date on my construction and programming progress.
Before we take a look at the final product installed Robby, I do want to take a closer look at the two different types of filament that I've used in making two different versions of Robby's mouth and talk about just what I notice as the advantages or disadvantages. First of all, I've been saying 320 millimeters for the longer piece. It's actually 360 millimeters, so I apologize there. But the normal pieces that you find everywhere are 300 millimeters. That's this piece on the top. And you'll notice it's more whitish. I find that the substrate that the LEDs are printed on is generally more translucent, so there's really no bad side to it. It shines brightly no matter how the LED filament is twisted. On the bottom, yes, it is a little bit longer, and I'm not sure this is coming out in the video. I'm not sure if that extra length was achieved by spacing the LEDs a little bit further apart or not. Regardless, if you do add more LEDs with the same amount of voltage, obviously it's going to be a little bit dimmer. I think the LEDs are more noticeable, and I think the substrate is a little more copper colored. It's a little bit less translucent than the sample on the top. So as a result, this definitely has a camera-friendly sign that's a little bit of a brighter side. And it generally, the coating is clear and not as translucent, so it doesn't diffuse the LED light as well. So why would you use the 360 instead of the 300? Well, as I've mentioned before, the tubes are just slightly longer than 300. So as you'll see in the demos, when I use this type of filament, it's a little bit shorter. It doesn't stretch end to end. And the advantage here is it's going to more closely look like the original neon because it's going to go from end to end inside. It's going to fill the entire tube. So each one is going to have its advantages and its disadvantages. Let's look at a side-by-side comparison, and please leave a comment, leave your thoughts. Let me know which version of the mouth you think looks better. And hopefully the camera will actually pick up some of these differences. Always a little bit challenging filming some of this stuff. I almost forgot. How are we going to actually install the mouth inside Robby? I have made these little posts here on the side, these little attachment brackets. In mine, I have glued them inside, and there's a hole on the side there. I've just slipped a screw through that, through the corresponding hole in the mouth frame itself, and that is how I am mounting the frame. There's also another little tab here on the side if you want. If you find you need to sort of pull the frame in tighter to the inside of Robby's head. I haven't had to use that, but I added the holes there. And so that's just one approach. You can use those. You can print these pieces out. There's probably a lot of other different ways with zip ties, etc., that you could do the mounting. Finally, it's time for that demo. Now, it's really hard to look at the LED filament and get it to record perfectly on video. But what I want you to pay attention to is basically how in the 300 millimeter version, the strips don't quite go to from end to end on the mouth, but they do in the 360 millimeter version. They look very similar once they're installed. They look really great, and I think whichever way you decide to go, it's going to look fantastic.
That is correct, sir. For your convenience, I am monitored to respond to the name Robby. 480 pipes, as you requested. Total, 60 gallons. I am monitored to admit no one at this hour. If you do not speak English, I am at your disposal with 187 other languages along with their various dialects and subtongues. In my case, sir, the question is totally without meaning. My beams are focused on your blasters, gentlemen. Quiet, please. I am analyzing. Sorry, miss. I was giving myself an oil job. Yes, relatively simple alcohol molecules with traces of fusel oil. That is true, sir. Yet I am monitored to admit no one. That was a long one. Thank you for watching, and we'll see you next time.